Chapter 11 of Aeroplanes and Dirigibles of War by Frederick A. Talbot. This Librivox Recording is in the public domain. Recording by William Tomcho. Aeroplanes and Dirigibles of War by Frederick A. Talbot. Chapter 11 Armored Aeroplanes. The stern test of war has served to reveal conclusively the fact that aerial craft can be put out of action readily and effectively when once the marksman has picked up the range, whether the gunner be conducting his operations with an anti-aircraft gun stationed upon the ground or from a hostile machine. It will be remembered that Flight Commander Briggs, on the occasion of the daring British raid upon the Zeppelin sheds at Friedrichshafen, was brought to the ground by a bullet which penetrated his fuel tank. Several other vessels, British, German, French, and Russian alike, have been thrown out of action in a similar manner, and invariably the craft which has been disabled suddenly in this way has fallen precipitately to earth in the fatal headlong dive. Previous to the outbreak of hostilities there was considerable divergence of opinion upon this subject. The general opinion was that the outspread wings and the stays which constituted the weakest parts of the structure were most susceptible to gunfire, and thus were likely to fail. But practice has proved that it is the driving mechanism which is the most vulnerable part of the aeroplane. The vulnerability of the essential feature of the flying machine is a decisive weakness, and exposes the aviator to a constant menace. It may be quite true that less than one bullet in 1,000 may hit the machine, but when the lucky missile does find its billet, its effect is complete. The fact must not be overlooked that the gunners who work the batteries of anti-aircraft guns are becoming more and more expert as a result of practice, so that as time progresses and improved guns for such duty are rendered available, the work of the aviator is likely to become more dangerous and difficult. Experience has proved that the high-velocity gun of today is able to hurl its projectile or shell to an extreme height, far greater than was previously considered possible, so that considerable discretion has to be exercised by the airman who literally bears his life in his hands. Although elaborate trials were carried out upon the testing ranges with the weapons devised especially for firing upon flying machines, captive balloons being employed as targets, the data thus obtained were neither conclusive nor illuminating. The actual experiences of airmen have given us some very instructive facts upon this point for the first time. It was formerly held that the zone of fire that is to be considered as a serious danger was within a height of about 4,500 feet. But this estimate was well within the mark. Airmen have found that the modern projectiles devised for this phase of operations are able to inflict distinctly serious damage at an altitude of 9,000 feet. The shell itself may have but little of its imparted velocity remaining at this altitude, but it must be remembered that when the missile bursts the contents thereof are given an independent velocity, and a wide cone of dispersion which is quite sufficient to achieve the desired end, inasmuch as the mechanism of the modern airplane and dirigible is somewhat delicate. It was for this reason that the possibility of armouring the airship was discussed seriously, and many interesting experiments in this field were carried out. At the same time it was decided that the armouring should be effected upon lines analogous to that prevailing in warship engineering. The craft should not only be provided with defensive, but also with aggressive, armament. This decision was not viewed with general approbation. It was pointed out that questions of weight would arise, especially in relation to the speed of the machine. Increased weight, unless it were accompanied by a proportionate augmentation of power in the motor, would react against the efficiency and utility of the machine, would appreciably reduce its speed, and would affect its climbing powers very adversely. In some quarters it was maintained that as a result the machine would even prove unsuited to military operations, inasmuch as high speed is the primary factor in these. Consequently, it was decided by the foremost aviating experts that machines would have to be classified and allotted to particular spheres of work, just as warships are built in accordance with the special duty which they are expected to perform. In reconnaissance, speed is imperative, because such work in the air coincides with that of the torpedo boat or scout upon the seas. It is designed to acquire information respecting the movements of the enemy, so as to assist the heavier arms in the plan of campaign. On the other hand, the fighting corsair of the skies might be likened to the cruiser or battleship. It need not possess such a high turn of speed, but must be equipped with hard-hitting powers and be protected against attacking fire. One attempt to secure the adequate protection against gunfire from the ground assumed the installation of bullet-proof steel plating, about 1/5 of an inch thick, below the tank and the motor respectively. The disposition of the plating was such as to offer the minimum of resistance to the air and yet to present a plane surface to the ground below. So far as it went, this protection was completely effective, but it failed to armor the vital parts against lateral, cross, and downward fire while aloft. As the latter is more to be feared than the fire from the ground, seeing that it may be directed at point-blank range, this was a decided defect, and the armor was subsequently abandoned as useless. The only effective method of achieving the desired end is to armor the whole of the carriage or fuselage of the aeroplane, and this was the principle adopted by the Vickers Company. The Vickers military aeroplane is essentially a military machine. It is built of steel throughout. The skeleton of the machine is formed of an alloy which combines the qualities of aluminum and steel to ensure toughness, strength, and lightness. In fact, metal is employed liberally throughout, except in connection with the wings, which follow the usual lines of construction. The body of the car is sheathed with steel plating which is bullet-proof against rifle or even shrapnel fire. The car is designed to carry 2 persons. The seats are therefore disposed tandem-wise, with the observer or gunner occupying the front seat. The defensive armament is adequate for ordinary purposes. Being fitted with a 100 horsepower motor, fairly high speeds are attainable, although the velocity is not equal to that of machines constructed upon conventional lines, inasmuch as there is an appreciable increase in weight. The car is short and designed upon excellent streamlines, so that the minimum of resistance to the air is offered, while at the same time the balancing is perfect. The sides of the car are brought up high enough to protect the aviators, only their heads being visible when they are seated. The prow of the car follows the lines generally adopted in high-speed torpedo boat design. There is a sharp knife-edged stem with an enclosed forecastle, the latter housing the gun. Another craft, designed for scouting operations, may be likened to the mosquito craft of the seas. This machine, while a biplane like the military aeroplane, is of lighter construction, everything being sacrificed to speed in this instance. It is fitted with a 100 horsepower motor and is designed to carry an observer if required. There is no offensive armament, however. The fuel tank capacity, moreover, is limited, being only sufficient for a 2 or 3 hours' flight. While this is adequate for general reconnoitering, which for the most part entails short high-speed flights, there are occasions when the staff demands more prolonged observations conducted over a greater radius. This requisition can be met by eliminating the observer, whose duties in this instance must be assumed by the pilot, and substituting in place of the former a second fuel tank of sufficient capacity for a flight of 4 or 5 hours, thereby bringing the term of action in the air to about 6 1/4 hours. This machine travels at a very high speed, and is eminently adapted to its specific duty, but it is of limited service for general purposes. The arming of an aeroplane, to enable it to defend itself against hostile attack, or to participate in raiding operations upon the aerial fleet of the enemy, appears to be a simple task, but as a matter of fact it is an undertaking beset with difficulties innumerable. This is especially the case where the aeroplane is of the tractive type, that is to say, where the propellers are placed in the forefront of the machine and in their revolution serve to draw the machine forward. All other considerations must necessarily be sacrificed to the mounting of the propeller. Consequently, it is by no means easy to allot a position for this installation of a gun, or if such should be found, there is grave risk of the angle of fire being severely restricted. In fact, in many instances the mounting of a gun is out of the question. It becomes a greater menace to the machine than to the enemy. The French aeronautical section of the military department devoted considerable study to this subject, but found the problem almost insurmountable. M. Loiseau met with the greatest measure of success, and his system is being practised in the present campaign. This principle is essentially adapted to tractor aeroplanes. Forward of the pilot a special position is reserved for the gunner. A special mounting is provided towards the prow and upon the upper face of the body of the machine. The gun mounting is disposed in such a manner that it is able to command a wide arc of fire in the vertical plane over the nose of the machine and more particularly in the downward direction. The marksman is provided with a special seat, but when he comes into action he has to stand to manipulate his weapon. The lower part of his body is protected by a front shield of steel plate, a fifth of an inch in thickness, while a light railing extending upon either side and behind enables the gunner to maintain his position when the aeroplane is banking and climbing. The machine gun, of the Hotchkiss type, is mounted upon a swivel attached to a tripod, while the latter is built into the bracing of the car so as to ensure a fairly steady gun platform. While the gun in the hands of a trained marksman may be manipulated with destructive effect, the drawbacks to the arrangement are obvious. The gunner occupies a very exposed position, and although the bullet-proof shield serves to break the effects of wind when travelling at high speed, which renders the sighting and training of the weapon extremely difficult, yet he offers a conspicuous target, more particularly when the enemy is able to assume the upper position in the air as a result of superior speed in travelling. The gun, however, may be elevated to about 60 degrees, which elevation may be accentuated by the inclination of the aeroplane when climbing, while the facility with which the weapon may be moved through the horizontal plane is distinctly favourable. But the aerial marksman suffers from one very pronounced defect. He has a severely restricted survey of everything below, since his vision is interrupted by the planes. The result is that an enemy who has lost ascendancy of position is comparatively safe if he is able to fly immediately below his adversary. The mitrailleuse of the latter cannot be trained upon him. On the other hand, the enemy, if equipped with repeating rifles or automatic pistols, is able to inflict appreciable damage upon the craft overhead, the difficulties of firing vertically into the air notwithstanding. In the Vickers system, where the propeller is mounted behind the car, the aeroplane thus operating upon the pusher principle, the nose of the car is occupied by the arm, which is a rifle calibre machine gun fitted upon a special mounting. The prow is provided with an embrasure for the weapon, and the latter is so installed as to command an angle of 30 degrees on all sides of the longitudinal axis of the machine when in flight. In this instance the marksman is provided with complete protection on all sides, inasmuch as his position is in the prow, where the hood of the forecastle shields him from overhead attack. The gun is protected by a special shield, which moves with the gun barrel. This shield is provided with mica windows, through which the gunner is able to sight his arm, so that he is not inconvenienced in any way by the wind draught. One shortcoming of such methods of arming an aeroplane will be observed. Ahead firing only is possible. The weapon cannot be trained astern, while similarly the line of fire on either broadside is severely limited. This is one reason why the machine gun armament of aerial craft of the heavier than air type has not adequate extensive development. In many instances the pilot and observer have expressed their preference for repeating high velocity rifles over any form of fixed gun mounting, and have recourse to the latter only when the conditions are extremely favourable to its effective employment. Efforts are now being made to equip the military type of aeroplane with both forward and astern firing guns. The urgency of the astern fire has been brought home very vividly. Suppose, for instance, two hostile aeroplanes, A and B, are in the air. A has the advantage at first, but B is speedier and rapidly overhauls A. During the whole period of the overhauling movement the gun of B can be directed upon A, while the latter, owing to the arc of training being limited to CD, cannot reply. Obviously, in the running fight it would be to the advantage of B, although the fleeter machine, to keep behind A, position 1, but the latter is making towards its own lines. Under these circumstances A must be headed off, so B crowds on speed to consummate this end. But in the overtaking process B renders his gun fire ineffective, inasmuch as B passes beyond the arc of his gun, which is represented by EF. But in so doing B comes within the firing arc of A, position 9. To minimize this danger B ascends to a higher level to obtain the paramount position. If, however, B were equipped with an astern gun, the aeroplane A would be within the fire of B when the forward gun of the latter could not be used. Similarly, if A were also fitted with an astern gun, it would be able to attack its pursuer the whole time B was in its rear, and in this event, if its gun fire were superior, it would be able to keep the latter to a safe distance, or compel B to maneuver into a superior position, which would entail a certain loss of time. An astern firing gun would be valuable to B in another sense. Directly it had passed A or brought the latter within the zone of its astern gun, it could maintain its fire at the most advantageous range, because owing to its speed it would be able to dictate the distance over which shots should be exchanged, and if mounted with a superior weapon would be able to keep beyond the range of A's guns, while at the same time it would keep A within range of its own gun and consequently rake the latter. In the interests of self-preservation, A would be compelled to change its course. In fact, B would be able to drive it in any direction he desired, as he would command A's movement by gunfire. The value of combined ahead and astern firing has been appreciated. But there is one difficulty which at the moment appears to be insuperable, the clearance of the propeller. At the moment astern firing, if such it may be called, is maintained by repeating rifles, but this armament is not to be compared with machine gun firing, as the latter with its capacity to pour 400 to 600 shots a minute is far more deadly, particularly when the weapon is manipulated by a crack gunner. Up to the present the offensive armament of aeroplanes has been confined to light machine guns such as the Hotchkiss, Berthier, Schwartlos, and Maxim weapons. So far as the arming of aeroplanes is concerned, the indispensable condition is light weight. With airships this factor is not so vital, the result being that some dirigibles are mounted with guns throwing 1-pound bursting shells fitted either with delay action or percussion fuses, the former for preference. These shells are given a wide cone of dispersion. Experiments are also being made with a gun similar to the pom-pom, which proved so useful in South Africa, the gun throwing small shells varying from 4 to 8 ounces in weight at high velocity and in rapid succession. While such missiles would not be likely to inflict appreciable damage upon an armoured aeroplane, they would nevertheless be disconcerting to the aviators subjected to such fire, and in aerial combats the successful undermining of the adversary's morale is of far greater importance than in land operations, since immediately ascendancy in the artillery operations is attained the final issue is a matter of moments. But the most devastating arm which has yet been contrived for aerial operations is the light machine gun, which has recently been perfected. The one objective with this weapon is to disable the hostile aircraft's machinery. It fires an armor-piercing projectile which, striking the motor of any aircraft, would instantly put the latter out of action. The shell has a diameter of about .75 inch and weighs about 4 ounces. The gun is a hybrid of the mitrailleuse and the French 75, combining the firing rapidity of the former with the recoil mechanism of the latter. This missile has established its ability to penetrate the defensive armouring of any airplane and the motor of the machine at 1,000 yards range. This offensive arm is now being manufactured, so that it is likely to be seen in the near future as the main armament of aeroplanes. At the moment widespread efforts are being made in the direction of increasing the offensive efficiency of aircraft. It is one of the phases of ingenuity which has been stimulated into activity as a result of the war. End of Chapter 11. Recording by William Tomcho.